See dear students, now we are solving some important problems, okay, basing on nth term of an AP. So now find the number of terms of the AP 3, 6, 9, 12 and so on, 111. So here you see this is clearly an AP, okay. So as the part of solution, okay, take the first term which is 3 and the common difference which is A2 minus A1 which is equal to 6 minus 3 is equal to 3. So you take A and D. Now you need to find the number of terms of the AP. So you can find the number of terms of the AP depending on the last term. So you please consider that last term is 111 which is AN. So in arithmetic progression, AN is A plus N minus 1 into D, which is equal to 111. So A is 3, 3 plus N minus 1 into D is 3, is equal to 111. So by transposition, N minus 1 into 3 is equal 111 minus 3. So N minus 1 into 3 is equal 111 minus 3 is 108. So n minus 1 is equal 108 by 3 plus n minus 1 is equal 36. So n is equal 36 plus 1. So n is equal 37. Therefore the number of terms of this given AP are 37. Understood? 37 terms are there. So number of terms is equal to 37. So this ends the problem. The next question is which term of the AP phi 2 minus 1 and so on is equal to minus 22. So he is asking here which term of the AP phi 2 minus 1 is equal to minus 22. So solution. So from the given AP you get A is equal 5 and you get D is equal A2 minus A1 which is equal to 2 minus 5 which is minus 3. Now which term is minus 22 is asking. Let us consider AN is minus 22. So AN is A plus N minus 1 into D equal to minus 22 and A is 5 plus N is N only and D is minus 3 equal to minus 22. Now by transposition what you get? N minus 1 into minus 3 is equal, are you following? Minus 22 minus 5. So then N minus 1 into minus 3 equal to minus 27. Are you following? Then this minus minus get cancelled. So N minus 1 is equal 27 by 3. So n minus 1 is equal 9. N is equal to 10. Therefore 10th term is equal to minus 22. I think you understood. So next question is find AN of an AP. Find AN of an AP in which A7 is equal minus 1 and A16 is equal to 17. So what he is asking is to find the nth term of an arithmetic progression. In that arithmetic progression, the 7th term is minus 1 and the 16th term is 17. So now solution. take the given information in an AP. Given that A7 is equal minus 1. A7 means A plus 6D equal to minus 1. We also given that A16 is equal to 17. This implies A16 means A plus 15D equal to 17. Now take these equations together and solve. So by subtracting, symbols get changed, then this plus A minus A get cancelled. Now 6 minus 15D gives you minus 9D is equal to minus 18. Now this minus and minus get cancelled. D is equal to 18 by 9. So D is equal to 2 you get. Now you substitute this D value 2 in equation 1. So substitute D value in A plus 6D is equal to minus 1. You got D is 2. So A plus 6 into 2 is equal to minus 1. So A plus 12 is equal to minus 1. This implies A is equal to minus 1 minus 12 implies A is equal to minus 13. So you got A value minus 13 and D value 2. Now you need to find nth term. Therefore nth term of the AP is A plus n minus 1 into D. So now you substitute A and D values. So A value is minus 13 plus n stands for n. To D value got 2. Are you following? So this is equal to minus 13 plus 2n minus 2, which is equal to 2n minus 15. So that nth term of the AP is 2n minus 15. I think you understood. So now let us go to next question. How many numbers of 2 digits are divisible by 7? This is a question. How many numbers of 2 digits are divisible by 7 is asking. So solution. Now obeying the given condition, the first 2 digit number which is divisible by 7 is 14. First 2 digit number which is divisible by 7 is 14, and next 21, next 28, and so on. Are you following? And the last 2 digit number which is divisible by 7 is 98. Do you agree? 7 ones are 7, 2 7, right, 98. So 99 is the last 2 digit number, but it cannot be divisible by 7. So this is the progression of all 2 digit numbers which are divisible by 7. So here A is equal to 14 and D is equal to A2 minus A1 equal 21 minus 14, which is 7. So how many such numbers are there is asking. So consider AN is equal to 98. So AN means A plus n minus 1 into D equal to 98. So what is A? 14 plus n minus 1 into 7 is equal to 98 plus n minus 1 into 7 is equal to 98 minus 14. So n minus 1 into 7 is equal, if you subtract 14 from 98, what do you get? 84. So this is 84. So this implies n minus 1 is equal 84 by 7. So n minus 1 is equal 7 12s are 84. So n is equal 12 plus 1, which is equal 13. So there are 13 two-digit numbers which are divisible by 7. Our next question is find the 10th term of 10th term from the end of the AP four, 9, 14 and so on to 54. We have to find the 10th term from the end, not from the begin. From the end you have to find the 10th term. Are you following? So for this you have to reverse the progression. Okay, when the terms are reversed, then what do you get? 254. See here, how much the common difference is there? 4, 9, 14, 5 common difference is there. So 254, 249. Are you following? Next 2. Are you following? No? So 244, 254, 249, 2. Okay, 244 and so on. 14, 9, 4. So this is a given progression. He is asking us to find the 10th term from the end. For that what I am doing is I am reversing the terms. Okay, here in the given progression the common difference is 5. So in the reversed progression the common difference would be minus 5. So the reversed progression is here. Now the 10th term from the last of the progression 1 is as the 10th term from the begin of the reversed progression. Okay, so if you find if you want 10th term from the end of this progression, you find 10th term from the begin of this progression. So here you take A10. AN is equal A plus n minus 1 into D. Go for A10. So what is A? 254 plus 10 minus 1 into D is minus 5. So this is equal 254 plus 10 minus 1, 9 into minus 5. So 254 minus 45. So from 254 subtract 45. 14 minus 5, 9. 4 minus 4, 0. So it is 209. Okay. Therefore the required 10th term in this progression is 209, which is 10th term from the end of the given progression. Therefore the 10th term from the end term from the end of 1 of AP given by 1 therefore the 10th term from the end of AP given by 1 is equal to 209. You understood, I think?